Hello, everybody, and welcome to Sparring Partners. This is Monica Paolini, Safiri, and I'm your host. And my guest today is none other than Rick Fulwiler, and he is the Senior Director of Product Management at NETSCOUT. I've known Rick for a long time, and we had countless conversations around how to use AI well. And I guess it's a very generic way to look at it. But what I mean is that, we often have, AI clearly is going to be a game changer. It's a huge opportunity, but we also have to be careful because it's so powerful and it can do so many things that it can also do a lot of things wrong. It can be, introducing things that we were not looking for. And so we have to be extremely careful how we use it to make sure that AI helps us and does what we want it to do. And we do not become the victims of its power. So the question is, how do we do it? How do we think about it? How do we make sure that we get the advantages of AI and protect ourselves from the potential dangers? And now I don't want to sound too negative here, but I think that we have to be extremely careful in terms of making sure that we get the positives and minimize the negatives. So, Rick, thanks for being with us today.
Definitely, Monica, and I really appreciate you having me on the show today. So I think it's really a great question because, obviously, as you look at the power of AI, people start believing in it. But unfortunately, if it gets it wrong, people are not going to be using it, right? And they're going to not use it. And I think really what drives the usability of AI is really the data sources itself. And I think this is the common misunderstanding is that generally, especially when you look at it from a carrier's perspective, they say, well, there's lots of data that I'm generally using, whether it's KPIs, dashboards, alarm information, metrics coming in, maybe even NEM information. And they're taking that same information that's feeding dashboards today and KPI views, and they're now pumping that back into an AI environment, expecting something magical to happen. But I think what we don't understand is that information wasn't really built for AI. That information was built for humans. It was built for dashboards for humans to look at things. It was built for humans to see, what's going wrong and how to use other tools to start investigating based upon, what's being delivered by that information. So I think it goes back to making sure we understand what is the right data to feed AI and not looking at the traditional data that we're feeding ourselves as humans, but we need to think about what is the right data and that we need to be feeding AI.
Absolutely. And, it's really important because you need to understand both how humans use information and both AI uses information. Because in this case, it's not so much that you have wrong information. So if you have an LLM out in the kind of LLM that we use in our daily lives, that obviously looks at everything that's available on the internet, which might be correct or not. So it might be just wrong information that it looks like. Now, in the case of a network, I think that the dangerous, and correct me if I'm wrong, is not so much that the data is inherently wrong. It's just not presented at the right level of granularity, or it's not the right data that is presented at the right time or in the right way. And because it comes from different vendors, different sources, it's all, So the problem is not so much that the data is not correct, right, or that it's a fake data, or which is what we have in the real internet. It's just that it's not presented to the AI model in the right way, and that creates a lot of noise and a lot of problem. Is that a fair way to?
I think definitely. I think that's a good point, and I think it goes back to kind of the opening statement about making sure that we leverage the right data. For example, if you look at some of the traditional sources of data, you have alarm information, you have log information, you have NEM event information. A lot of that data is looking at symptoms that are taking place in the network. For example, if you look at alarms, a lot of the alarms are threshold-driven events, and by the time the alarm fires, users are already impacted. And generally, under heavy load conditions, alarms may be somewhat delayed. And you have other issues where you have this concept of alarm storms. This is where one failure in the network can generate hundreds, if not thousands, of alarms. The nice thing is that when this alarm information, for example, is fed into AI learns correlation, but it doesn't learn causality. It doesn't understand what's generating that root cause. So this is why I think we need to go back and understand, what type of data should we be feeding AI? And we have a lot of sources. When you look at the type of sources that we can start feeding AI today, rather than looking at the KPI information or rather than looking at log information or NEM events, we have the ultimate ground truth, which is the packet level information. Whether we're bringing in from the packet core or we're bringing it in from the radio access information. And one of the key things that this data starts to add, it adds the visibility of the subscriber. So anytime that you have incidents related to log information or alarm information, you don't understand who is affected. You don't understand the number of subscribers that are affected. So your blast radius is really not understood. I think this is what really packet level data brings to the table, is that subscriber level view.
Yeah, and absolutely, and I think that maybe you can give us an example of what is that humans can and do appreciate and can act on, and the AI cannot. Because I would imagine that a lot of, like, well, not a lot, raw packet data is completely useless to a human looking at it because it's just so much detail you can't possibly make sense of it unless something kind of extracts what's relevant in there. I mean, you might be
Definitely.
able to see some of it, but it's really, like, okay, that would make it a really heavy kind of job to do. But the alarm makes a lot of sense to humans. But as you say, maybe to the AI, well, it's relevant, but it doesn't tell you what's creating it.
Right, right. And that's
Yeah.
really kind of the key. In fact, you're right. Possible if you take a Wireshark type of packet, you look at a PCAP dump, you can see some information, but you really don't understand what's really going on, right? Obviously you just can't take raw packet level data and just inject it into an AI machine and sprinkle some magic on top of it and expect some things to really come out. It's a lot of data, right? At the end of the day. In fact, when you look at packet level data that's being generated, it's like taking the transcript of every conversation inside of a football stadium, right? I mean, you go mad, right? Inside of say a 10 million sub network, you're looking at probably somewhere around 9 terabytes of data per day, and it's just a lot of information. Not only is the information we would drown the AI agent in noise, it would be extremely expensive from the tokenization process to be able to tokenize that information and have AI process that. So the key to this is how do we go through the process of curating or stitching this information together so AI can understand the entire process at a session level, all the way from the radio access part of the network back into the packet core. And I think this is why it's so important that packet level data has the richness. It has that subscriber context. It understands what's going on the radio network. But the key is being able to stitch that together with context and add the right intelligence on top of that through the curation process, and then feed that into AI. And it's kind of a two-step process. For example, for one of the things that it's really important is when we have this packet level information, we have a lot of the data which is binary. We have some of the data which is now in JSON format as you migrate to 5G standalone. But you also have this concept of ephemeral identifiers. You have things which are called global unique temporary identifiers on the radio access side. You have TEIDs on the user plane side, and you have this concept of subscriber permanent identifiers, which is the SUPI, along with the IMSI information that needs to be stitched together. So the key part of this is how do I stitch all that together, all the way from that packet level information going across all the multiple different network elements, along with the radio parameters, and provide a nice correlated session timeline on what happened to all the subscribers, and then deliver that records back into the AI engine.
Absolutely. So let's go from curation to token reduction here. Try to kind of break it down a little bit.
Sure.
Because so the first temptation is like, well, AI can just process any amount of data, so we give it the more the merrier. That's not true. You need to curate it, meaning
Yes.
pick what you think is. So you need to have some sort of understanding. I mean, I guess that's intent, right? So you need to understand what is that you're trying to achieve, because depending on what you try to achieve, you might curate the data in a different way. Is that right? Or there is no universal way to actually curate the data. It's not like it's not a pass. Like before you feed you to AI, that's what you need to do. That's not quite that way, right?
Well, I think there's a couple things. There's kind of this two-step process, and when you think about curation, is we talked a little bit about that previously. Is that we kind of stitch this together. We understand what's taking place from the packet core side back into the radio access side. But the key part of this is what are the right elements to stitch together. So there's also a lot of telecom knowledge that needs to be deployed during this curation process. It needs to understand timing. Timing on the radio access side is a little bit different than timing on the packet core side. So that needs to be integrated together. So we need to understand the time correlation associated with that. Then we also need to understand what's important to bring into that curation process. So there's this other step that sits above the overall curation, which is called kind of contextual intelligence. And what this adds to the table is it adds the fact that I want to see other procedures that are taking place as I have this record kind of being curated. I want to understand the non-access stratum procedures that happened if I had a failure, bring that into effect. Not only do I want to see that, but I also may want to see radio measurements. Maybe I want to also see policy decisions. So if I'm looking at a 4G network, I'm getting policy information from the PCRF, or I'm getting information from the PCF in a 5G network. So that's really critical. Maybe I want to also turn on deep packet classification or deep packet inspection at the same time. So I want to understand application behavior. What applications was the subscriber utilizing during this particular point in time? This is a lot of context, and this context is real important for the AI engine to be able to understand what is the root cause or what is the impact of something taking place. So this context can allow the AI engine to kind of distinguish between a session drop caused by a handover failure, maybe on the radio access side, or maybe a policy decision versus maybe I'm having a capacity problem on my UPF. And this is real important. The key to this is that as I stitch this together, I've gone from, say, terabytes of packet level information now to just maybe megabytes of now curated data. What the end result of this is the amount of tokens that I'm producing goes down by an order of magnitude. What we've seen during this curation process is close to a 90+% percentage, and that translates into power. It translates into water savings. It translates into GPU savings, memory costs, so on and so forth. So it's really a huge business case around this curation process.
Let's get to the token reduction in a second, but let's just step back. So is the context creation, which I guess is really important because it tells you what is that you should be focusing on. Because if I have whatever alert, so there's something going on here, but maybe the problem is not here. It comes from some other element in the network. So you need to kind of trace it back. And I guess that's context. So is that something that I guess humans have to do today, but eventually it's going to be being part of the automation? So how do you see the role of humans in doing the curation / context analysis? Or is it going to be always humans?
No, I don't think it's going to be always humans. I think it's going to allow the humans to focus on more of some of the corner cases, and also potentially be able to train the models a little bit better related to what may be unique to that particular type of network. The key part of this is having the humans understand that the AI engine has curated data already. So it's not going off and trying to hunt for things. It's trying to actually allow the humans to use AI as a tool to help solve problems. And I think that's really the key. Is you're not doing the same. The humans are not going to be doing the same thing as they've done before. Is they're going to be able to actually manage their workflow a lot faster and be able to solve problems faster. So it's not that AI is replacing them, it's allowing them to retrain them in what they're looking for and how they're leveraging the tools. It's kind of like going from a hand saw to an electric saw. I now can do things a lot better than I've done before in my past. It's not replacing me, it's actually allowing me to do my job a lot better. And I think it's going to be good for the subscribers too, because a lot of people are complaining about network quality issues, call drops, things like that. Allowing an AI agent to be able to ferret out these kind of issues in a matter of seconds versus what may take literally weeks, if not months, for a human is going to make subscribers' overall NPS scores start to go down. You're not going to see that churn.
Yeah, and in fact, unlike the alerts that you see today that come after the fact, you should be able to preempt and sort of predict, so you don't have to eventually deal with the alarm. You deal with, oh, something is coming up, be careful, type
Right.
of
Exactly. Yeah, and that's really kind of an interesting kind of point. When you think about looking at just KPIs today, a lot of this can get kind of muddled in the math. And if you think about this, and if you kind of take an example, let's suppose we're looking at maybe uh, cell coverage in a particular area, right? And humans are looking at their KPI dashboards, and all the KPIs are green, capacity's fine, signal strength is great. However, subscribers at the edge of that sector are struggling, but they're struggling in silence. And the reason why is because KPIs are averaging across thousands of users. Let's say in that particular sector, you have 5,000 connected devices, and 50 of them are experiencing really, really poor signal quality. So that's really only 1% of the population. Well, the problem with that is that that gets buried. You'll never see that needle move. However, over time, maybe weeks go by, all of a sudden that KPI will start getting a little yellow, maybe getting into the red. And at that point in time, maybe you've lost a large percentage of those subscribers because of the poor performance. So two things have happened. One is that that KPI was basically buried in the math. And the second part of that is you didn't relate that back to a particular set of subscribers. So you didn't understand what was going on at the subscriber level view. And this is really the key that also curation brings into the picture is now I have the ability to bring together what's happening on the packet core along with the RAN, bind that together in a nice, understandable record for AI to understand what's going on that subscriber's journey through the entire network, all the way from the radio access part of the network, all the way back into the packet core. And that's real important, I think.
Yeah, absolutely. And I think that that's an issue that, we always had with KPIs that are very good for, the slides that you have at the end of the quarter, but they're not very good at telling you why people are not happy because, as you say, it's not necessarily, the average doesn't tell you what is the individual experience, and the individual experience is all that matters. I mean,
Exactly.
it's not even how the RAN works, is how do subscribers feel about it.
Exactly.
Even if they were able to talk to you continuously, they would not necessarily even know. I mean, because it's not, you understand, you see that what you're not getting what you want, but you don't know why, even if you are a user. Even if you, Rick, I have the phone, you don't necessarily know what's going on. Why is that you don't get what you want?
That's
So
right.
that's
That's right.
exactly why you need a AI or something that is a little bit more than just a person looking at it, which, as a person, you just look at the average. You can't possibly look at the variation. So now, if we get now to token reduction, this is something that it's really important, I think, because so clearly, if you feed too much data, it's just you don't get the result that you want, regardless of how many tokens you're using. That's number one. But token reduction is really important because you oftentimes hear that AI is putting so much of a pressure. You need a lot of computation. You need the GPUs, so it's hugely expensive. And the thing is that it is hugely expensive if you feed everything. But then, as I say, if you curate the data, then the cost is less. But not only the cost is less, but the results are better because you're doing what you need to do. You don't do unnecessary work.
That's very true. You're exactly right. So something is going to have to curate the data at the end of the day. And obviously, there's no way that you could take the amount of packet data that's generated today off of the network and put it into an AI environment. And the first thing it has to go through, it has to go through that token process that you talked about. That has to be done for AI just to even to understand it. Whenever you take text information, you take in a PDF, you take in a Word document, it tokenizes that, and there's the cost associated with that. So anytime that you can reduce the amount of tokens being generated from that information, obviously there is a cost savings. The key to part of that is that just because I put more data in does not mean that I have a smarter AI engine. The key to this is that I have the right data that's going into it. And this goes back to the same thing we just talked about, that curation process. I have to have some level of curation so the AI engine can actually reason over the right information. It needs to understand that entire kind of chain, that causality chain. And once it understands that causality chain, it's easy for it to actually run its algorithms to determine, what is the potential problem. And I think that that's really the key is that we go back to the old adage of feeding, the same information we feed humans and expect AI to find something different that humans haven't found for X number of years. It's not going to do that. You have to go and have the right information, but you have to have the information not from a fire hose, but from that curated process. And as I said before, as we've seen, we've seen through curation a huge reduction of tokenization, and it saved literally millions of dollars for carriers to go through that process.
Yeah, and also, yeah, increased efficiency and all that. But let's say that, you have a client and you go and tell them you need to curate your data, you need to do that. But it might not necessarily be obvious on how to do it because, what is that? Okay, so let's say time granularity. I mean, you're gonna have a sense of what is the right ballpark, but you might not really know this. So there is a question of how the human component, interacts with the data and with the AI models to find the right level of curation. So how should humans approach this? Because it's not, you, Rick, are not gonna say, oh, you have to do this, 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 and this. It's not like a recipe, probably, right? I mean, it's a little bit of an art, or
Well,
is it
yeah, to some degree, I think it is on art, but at the same time, the information is there. For example, if you look at kind of the three main parts of the data that's being fed into the curation engine, I mean, you have control plane traffic, and you have the entire signaling life cycle of what's going on a per individual basis, right, on a per subscriber basis. So you have all the AMF registrations, you have SMF station establishments, you have all the policy decisions being made by the PCF. Then you have the user plane. So the user plane has the actual traffic flows that are being observed. You have all the QoS policies being deployed. Any degradation of QoS is there. Anything that related to the slice information is also there. And you have deep packet classification. So now you have all the applications, as I said before, that's being utilized. The trace port data from RAN brings in the added value of the radio measurements, RSRP, RSRQ, SINR, all that information, even beam level measurements are all there too. I think that the art of this, if you wish, is the telecom knowledge that's imparted by the vendor that does that curation to understand how to stitch things together, how to understand that. And that's kind of the secret sauce, And that's obviously something that NETSCOUT brings to the table, is kind of understanding how to bring that secret sauce to the table and provide that in a nice curated record for the AI engine. And I think that's really the key. There is ways of being able to do that, but it's maybe a little bit different from vendor to vendor, and we think we've done that pretty well over the years.
But isn't there also a challenge where, obviously you can help because you've been, dealing with different vendors all the time. So with through your clients. But isn't that, and I've heard it from other people, that it is an issue when you have different vendors with different data. So you need to curate not only your data set. What you're curating is not a uniform data set. It's a data set where you have a lot of variability depending on the vendor, depending on, and maybe not all the vendors are equally good at letting you access their data.
Well, I think that's kind of yes and no. So if you go back, the no part of that is if you have vendors providing, say, their own metrics. then that's true. How maybe one vendor provides their own NEM level metrics may be different than somebody else. But since you're using 3GPP packets, you're using basically a standard. Everybody has to conform to the 3GPP standard. So if I do a packet analysis, looking at the communication from, say, an AMF and an SMF from vendor A to vendor B, they should be 100% identical from vendor to vendor to vendor. Now, there may be some extensions, obviously that 3GPP allows, and those extensions generally are published and specified. And that's true. So 3GPP has done a great job of being able to provide those specifications and making sure vendors apply to that. The little bit of the nuances are related maybe a little bit more on the radio side. Sometimes on the radio side, vendors have some vendor extensions. The nice thing is that there are some standard bodies out there that follow that standard. OSSII is a great example of that. We have a consortium of vendors saying that we're going to provide these radio measurements, and everybody's going to provide the same radio measurements. So I think that's definitely important. And in fact, that's really a good thing for us, right? Because anytime you have a standard bodies like 3GPP or GSMA or things like that are out there pushing standards that vendors are following, then it's pretty universal in terms of how we're getting that information. And that's a lot different than looking at unique NEMS metrics or looking at unique NEMS KPIs, or you're looking at alarms. Alarms from one vendor can mean one thing versus somebody else. And I think this is the thing that's kind of interesting when you go back to the adage of humans injecting into this process. A lot of times humans go, oh, the KPIs from this NEM kind of means this, but if I get them from this NEM, it kind of means that, or if I get this from somebody else, it means this. Well, that's something that the humans know, but an AI agent doesn't know that. They think that information is ground truth. But now when you vector back over to the 3GPP, looking at packet information, you have ground truth. Packets are definitely the ground truth. And the nice thing about it is that literally you can go into a chat interface. So if you can go into Claude AI today and type in, what would you rather receive? Curated packet level information or alarms or this? It'll tell you without a doubt. It definitely wants to see the curated packet level information. No doubt about it.
No, absolutely. And I guess that in a way, AI might push for more kind of uniformity, so because that's crucial for everybody. Because in any network out there, you have multiple vendors. There's just no way to. I mean, you might have a larger number, a smaller number of vendors, but nobody has a single vendor network. So you need to be able to connect, and that might be a push to actually have more data that it's is coming in the same format, agreed interfaces and things like that. Now, we talked about generically about AI models, and so there is traditional. Well, it's not really traditional, but so traditional AI model, LM, ML, and then you have Gen AI, and then you have agents. How should we think differently? Do you curate data in different ways, and you think of token reductions differently for different type of models?
Not really. I mean, obviously, the model itself could be tuned a little bit uniquely for a particular type of network deployment or how that particular carrier wants to tune the models. And there's been obviously a lot of carriers talk about that. I think the key part of this is being able to provide the data through an open concept, and obviously, being able to leverage, the model context protocol MCP, provides that avenue. And at the end of the day, that allows any agent, whether it's an agentic agent environment or just any AI agent, to be able to subscribe to that MCP environment, and they can get packet derived metrics, they can get subscriber context, they can get radio conditions, they can get whatever they need through that common interface. And I think by leveraging that's real important, because at the end of the day, when you think about, now I have my data is housed in an environment where I have an MCP server sitting around that, and it's available to any AI agent that wants to subscribe to that data. So through an agentic environment, let's suppose that I did have a subscriber that churned. Well, what can happen now is that agent can go off and say, well, through MCP, tell me what will that subscriber's network experience over the last 48 hours. Now also show me their bill information. Now show me, what the device was measuring at this particular time. And all that information can be gathered together. And all that's very easily to be acquired through MCP. That same agent can actually go through multiple different paths to get that information. So it can make some very quick, intelligent decisions. Was the subscriber churning because they're related to a network condition? Was it a fact that maybe their bill had gone up and that wasn't caught? They can even correlate that back to maybe they're in friends and families or something like that, and somebody else, had also decided to churn too because of some other reasons. And you can get very sophisticated. You can do a lot of things related to social media scrubbing, things like that. So you can get really sophisticated with the AI agents. But the nice thing is you have that common protocol to be able to access that data.
Yeah, and I guess you kind of have a way to think about it so that whatever you're trying to look at, so if you look at churn reasons as opposed to network performance,
Mhm.
you have the same sort of baseline of data. I mean, the same initial set of data that then you go and pick whatever you need for different things, but you don't have to duplicate it every time.
That's right.
So
That's right.
there is some differences, but also some commonalities so that you can use. Again, it sort of goes into the way of the token reduction to make AI more efficient, because AI is going
Mhm.
to make our networks efficient as long as we use it in an efficient way. So it's kind of like you need to add efficiency in the process. Now, what is the role here for the NCP servers you mentioned?
Well, I think the role, as I said, is really being that standard interface. Now any AI agent can ask for data. As I said, can get the KPIs, you can get information about the subscriber, radio conditions, whether it needs. But it's that standard level of architecture. And if we didn't have that, you'd have to go back to kind of the old way of doing it. An AI application would need custom plumbing to talk to a network data. There's different query logic, there's different schemas, there's different access rules. So each vendor would have to build their own connector. Internal tools group would need to do the integration. So it gets very complex. And MCP replaces all that, right? It's now a single standard interface. And I think it's great. I think it's definitely the way of the future, no doubt about that. And I think now that you have agentic AI, it can get the data it needs through the MCP environment. And one MCP can actually talk to multiple different data sources at the same time too.
Yeah, absolutely. So your work is going to become much easier too, because you can actually you probably have to deal at NETSCOUT with less frustration about having to stitch everything together before AI came along, because there was so much more stuff to put together. Is that right?
Well, yes. I mean, definitely having a common interface, especially working with third parties, definitely makes life a lot easier. Now that once you say you have MCP, they all go, okay. Their agent can then talk to MCP server. MCP can publish which tools are available. That tells you what data is there, the schema and information, and it's a lot easier than it had been in the past. No doubt about that.
Now, when you go and talk to operators or your other clients, what do you think that they are culturally ready to deal with this? Because the dashboard experience is something that they're familiar with, they
Mhm.
know how to deal with, and they feel comfortable with it. So they need to do initially more work to curate all the data, to deal with this, make sure everything works in a different way. So that requires a lot of change, and to some extent a little bit of risk, in the sense that you need to do it right and you need to do things new, and introducing change is always expensive and hard. Do you think they're ready, or they're not, they are too aggressive or not aggressive enough?
Yeah, I think I think we're starting to see, it really depends upon the carrier and where they are kind of in that overall life cycle of the transformation process, right? And you talked a little bit about, where the human fits. I mean, in the past, you've kind of had this concept of human in the loop. Now I think you're kind of having human at the helm, not approving or looking at kind of these decisions, but setting objectives, setting guardrails, setting risk tolerances. especially as you get into more agentic AI and you're getting into more of a closed loop type of an environment. This is where you're starting to see humans being able to provide the guardrails of how much do we feel comfortable with the AI environment making automatic decisions within the network. This is where governance comes into play. So you're elevating where the human is in that overall process, right? Before they were kind of looking at KPIs and dashboards. Now they're deciding, when an AI just makes a decision, how far should we let that particular agent go? How much could it execute within my network? What are the right governances we need to put into place? How much risk tolerance do we have? Things like that. So it's actually providing a different form of what they've been doing, but now guiding the engine and guiding where it's going to go.
So do you think that people can do it? I mean, because I would imagine, if, I'm not one of them, obviously, but if I'm in charge, I might feel like I'm not sure if I'm doing things right here, and I don't want to lose my job because I've screwed up something. There is this, is that much of an issue, you think, being able, being able to learn to do something fundamental, in a fundamentally different way?
Right. Well, I think it's more of it's kind of a talent transformation. The NOC
Yeah.
engineers need different skills, right? I mean, they're not looking at alarms and dashboards as much as they used to. Now they're becoming system thinkers. They're becoming governing agents. Knowing when to override or when to trust AI. So they've elevated their skill levels. I think that's going to happen over time, right? And there's no doubt about that. Which I think is good. You're providing them with more responsibility. You're providing them with more, more tools to do their work, but doing their work a little bit differently.
Yeah, absolutely. But we also might need fewer people, which in telecoms, it might be a good thing because we have so much trouble finding talent that, and you see a bunch of people retiring, and then, who is going to replace them? So uh, it might be a situation where it's not so much firing people, it's just that, this is going to be a good way to make sure that everything will run appropriately.
I agree. Definitely agree. Yes. Yeah. Yeah. I think the organizations themselves need to put in the right organizational muscle to match that, right? And you're right. I think the investment is into the people to make sure they do that talent transformation. And at the same time, I think they need to understand, as people start to age out and to your point, retiring, how do I have that? How do I have my bench deep enough inside the organization, whether I'm leveraging humans or whether I'm leveraging AI to be able to replace that. And I think that's the organizational muscle that needs to be put into place that I'm sure that a lot of executives are thinking about today.
Now, when I think about agents, I always, in my mind, this image of all these agents moving around and fighting with each other in the same way that humans do. I don't know why I have this kind of like, but you can imagine, okay, obviously you're going to have orchestration to try to avoid
Mhm,
that.
mhm, mhm.
You can say the same in organizations. You have a structure where there is a boss that tells people what to do, but yeah, people do fight with each other. There is conflict and whatever. Isn't there a risk that we have the same with the different AI agents moving around?
Well, you're true, and then very true. In fact, if you look at the concept of what they consider domain agents, like you have domain agents maybe on the radio
Right.
access side of the network, or you have domain agents on the packet core, without the ability to have the domain agents communicate back to an orchestration layer, as you were saying, or sometimes they call that a change gate agent. Um, you could be making decisions on either one side or the other, on the radio side or the packet core side. They could be affecting one side or the other, but the problem doesn't actually happen on the radio access side or happen on the packet core side. I could be having a potential throughput issue that's not actually related to the radio access side. It could be related to a problem back on the packet core. So this is why having mobile agents communicate with each other through this orchestration layer, this change gate environment is actually very, very key. And this is where, the arbitrating takes place. This is where the governance comes into play. And this is where I think the intelligence of the human starts adding a little bit more information to that central controller and adding business logic to it too at the same time. Because, if you stop thinking about the central controller, as just an orchestrator, but start thinking about it as a consensus engine with business logic at the core, that's real important because somebody needs to deploy business logic inside of that gate agent. And that's really the key. Who does that? It's not going to be an AI agent. It's going to be somebody teaching it. And I think this is where the human comes into play.
Absolutely. Now we are at the very beginning of all this, and we're learning as we go, and clearly there's a lot of learning to do for everybody in the ecosystem, analysts, vendors, and operators. It's not just operators that need to change. So how do you see this evolving? Because, and there are different dimensions here. There is the maturity of the technology. There is how good we are at curating data in the most efficient way, how to do the token reduction, and how in all this, how is the role of humans going to change? So if you were to look at, what's happening in the future, how do you see the progression here?
Well, I think it goes back a little bit to what I was saying before. I mean, obviously, humans are not going to be making thousands of these micro decisions. They're going to be setting intent. They're going to be setting kind of the overall governance of the systems themselves. They're going to probably stay in the loop for some time for accountability sake. I think you are going to see, as I said, that talent transformation. You're going to see the NOC engineers transformed to probably a little bit of a different level inside the organization. No doubt about that. I think they probably will stay in the loop for some time, but I think over time they'll start pulling themselves away from that. And going back to the expression that I used, it's going to be humans more at the guidance level at the helm. Again, not making and improving individual decisions, but setting objectives, setting risk tolerances. Obviously, as you start having more agentic AI and starting to make automatic decisions and everybody's going to kind of level 4, autonomous networks and things like that, there has to be governments put into place to make sure that, we understand the risk associated with doing this. And this is the risk we want to take. How do we migrate from level 3 to level 4 or level 2 to level 3, then level 3 to level 4, things like that. This is where the human decisions come into place, and this is where they put those tolerances in. And this is where they actually understand how the agents are performing, and then they can get comfortable. Okay, we feel comfortable. It's making the right decisions. Now we release them going up to to the next level.
Yeah, absolutely. Yeah, and I guess that, as you said here, we need to learn to trust. We need to learn. I mean, we need to teach AI, but we also need to learn from AI how it operates so that we understand and we can, address again, get the best we can from it, but also avoid all the issues. So that's the whole, making sure that we're getting what we are asking for.
That's exactly right. And I think, this is one of the things that as the agents are developed is we have this concept of glass box, right? So we understand what's actually taking place inside of the agent, and it's providing evidence too. So this is where this kind of, as you said, this trust factor comes into play. In the past, we've always had the concept of black box. I feed information in, something comes out. I don't understand what's really happening inside. But I think a lot of the agents now are being developed in kind of this glass box environment where I'm telling you what I did, and I'm showing you evidence of how I made this decision. And by doing that, that's providing a lower risk, and it's providing more of a trusting environment for the humans.
Absolutely, because and that's the thing is that because they have so much, every AI model, whichever is an agent or a model, clearly is so much more powerful than we are in terms of computational capabilities. So it's very hard for us to really say, well, so how do you exactly you get there? And it's not necessarily the way that we do. So if you come up with something, I could probably kind of guess it because you're human, you're kind of we're constrained in a similar way. You might be smarter than me, but not by that order of magnitude. But the computational capabilities are in the same, order of magnitude. What an AI model can do, no human can do the same amount of number data cracking. Hey, Rick, Well, thank you so much. This was so much information that I think that we all need to take some time to kind of step back and say, "Oh, hold on," because that's I think it's really important to think about what's happening at the margin of AI. What is that allows it to, to do that? So, thank you so much for sharing your thoughts with us.
Definitely welcome. I appreciate it. Thank you again.
And we should again, as with many guests, we should go back and see what's happening and what is the impact of this, all of this, in like a year or so. So Rick, thank you so much again, and thank you all for listening in to this podcast. Continue listening to us and tell your friends about it.
Thank you.